Welcome to our NPTEL courses on power quality improvement technique. Today we are going to discuss UPQC, that is Unified Power Quality Conditioners, and its introduction and classification. So, UPQC is one of the main entity of the power quality mitigation improvement. The main objective of, as we have discussed earlier, the main objective of the electrical utility is to supply their customer an interrupted sinusoidal voltage of constant magnitude and frequency with constant balanced current in AC mesh. This is the power quality. But due to, as I told you in several time before, due to present day AC distribution systems are facing several power quality problems such as high reactive power burden. So, it is due to the industrial loading, and most of these are the induction machines, and due to that power quality due to the reactive power comes, and it may be due to the we have a 3-phase 4-wire system for the household applications, and due to that there is a unbalanced loading and harmonic rich load for adjustable speed drive. This is because it is a problem is that induction machines are the constant speed machine as a constant frequency, and for this reason to effectively run this machine we require a variable frequency. The moment we have adjustable speed drive with a variable frequency, we have a in between AC to DC AC conversion, and that leads to the harmonic rich current and with the excess neutral current. In addition, there are utilities are not able to avoid voltage sag. Maybe there is a high voltage line and the T is touching the this high voltage line, and from there it is a high current sinks through the ground, and thus there will be a sag, and maybe due to the wind it is touching and going back. So, there will be a pattern of the sag in the voltage of the consumer end, or there might be any other reasons there will be a sag, or maybe all of a sudden some consumer overthrow a heavy load, and due to that voltage will swell up and surges. So, that can be a phenomena like thunder strikes or anything, lightning strikes, snatches, spikes, splickers, unbalanced and harmonic supply in the voltage across the consumer end of the load. So, a custom device power devices like as I told you, that is unified power quality conditioner, or the sometime compensator we also say, is considered as a right option for the, it is sometimes called the banded option. So, you put where the it bleeded most. So, for this critical and the sensitive load to compensate both voltage and current based power quality problem. The UPQC is the combinations of the shunt, that is the this is the shunt path, and the series, that is DVR, compensates the it is integrated and makes as a one single solutions for mitigating this multiple PQ problem of voltage and current. So, this is the one single solution. Ultimately, if there is a voltage sags or swell or the harmonic problem, this will be mitigated by the series compensations, and if there is a unbalanced load and all, due to that there is a harmonic problems or the reactive power problem, ultimately D STATCOM will inject the current, it is a voltage controlled current source inverter, and correct and make this load current sinusoidal, as if this load will see that it will be behaves like a resistive load. So, it will be all mitigated from the voltage and current quality problem. So, the power circuits of the UPQC, as I shown you, consist of the two voltage converter or voltage control current source or current source inverter. Generally current source is preferred for the shunt part of the compensations, joined back to back by a common DC link capacitor in case of the VSC and or with an inductor in case of the CSC as a DC bus respectively. So, shunt devices of the UPQC is known as the D-STATCOM, because we have studied facts that we use the STATCOM, but that is connected in the transmission level, and generally it is connected in a distribution level in a consumer side. For this it is called D-STATCOM, or sometimes it is referred only this part of it, shunt compensation is called the shunt active power filter, which provides all those compensations, that is reactive power compensations, load balancing. If the load is unbalanced, then it can balance the load, even the single phasing, the neutral current compensation. If it is a 3 phase 4 wire system, this cause arises. So, neutral current can be compensated by this D-STATCOM, and elimination of the harmonic, mostly this is the task of the shunt active power filter, and it connects parallel to the consumer load. It is something like over excited conditioner or condenser, but it can mitigate also not only the reactive power, but also the unbalanced as well as the zero sequence component of the current and harmonics, and for this reason it gives a total solution for the problem arises due to the current. And same way the series devices are also known as DVR. The full form of the DVR is dynamic voltage restorer. Mostly in India the problem is a SAC. So, for this reason it mitigates, sometimes we have a SAC compensator, but it can act both as a actually SAC compensation or SOL mitigator. It keeps the consumer loads and the voltage ends sensitive to the voltage supply, and it gives a quality voltage to the consumers, and so it mitigates sags and swell, surges in the voltage, surges, spikes, notches, fluctuations, that is basically depression. Depression is a long time sag. So, there is a definition we have already discussed in our previous classes. So, as well as the unbalanced of the voltages that it is coming due to the source end. DVR injects the compensating voltage between the supply and the consumer load and restores the load voltage to its reference value. This is the task of the DVR. Now, if you integrate these two entities, then it comes with a single package, then we call it is the UPQC. UPQC which is combinations of the series and shunt compensators proposed as a single solution for mitigating the multiple power quality problem which we are telling from the initiation of these courses. The cost of the PQ, that is the power quality, to manufacturer and the emergency services together with the requirement of improved power quality in the current waveform justifies the complex, and now I will not set the complex control technique. Now, we have this may be a case to be told around 20 years ago, where writing a FPGA code was a big challenge and very few skilled levels were available, professionals are available, I should not say skilled levels. And so, this complex control, implementation of the complex control are now a well proven technology. For this reason, and cost of the switching devices now drastically coming down, and thus we have now a greater validity, financial validity for going for the or case for going for the UPQC solutions. Now, next part comes that how you to control. We are saying that it is a complex control. So, we require to see that what are these controls, and as it has been mentioned here, many control techniques and the topologies are reported for the control of the UPQC. We shall discuss few of them. It is not possible to take up the whole all the control technique already reported, and we shall take few important techniques. And the energy storage element as a DC bus is also used for the preparation of an alternate unified power flow conditioner. The D-STATCOM and the DVS are controlled separately for power quality enhancement in the current and voltage respectively, shunt for the current and the series for the voltage. Most of the control algorithm reports, the D-STATCOM and the DVR are applied to the, are combined and gives the, works as a UPQC. And there are many solutions, there are fewer time domain, there are fewer voltage domain. For example, this is a famous theory, it is proposed by Akagi in 1984. So, it is already 35 years. So, instantaneous reactive power theory and synchronous reference frame theory, mostly it is proposed by Deepak Divan and others. Thereafter, from this we have a soft computing technique based algorithms, that is fuzzy logic algorithms, and thereafter Akagi and Nobe proposed little later, that is instantaneous symmetrical component theory. This is instantaneous reactive power theory is valid for 3-phase 3-wire system, and as you have seen that the generally UPQC works in the domain of the D-STATCOM, then we require to incorporate 3-phase 4-wire system. And for this reason we have found that zero sequence component compensation is not good in instantaneous reactive power theory. And for these reasons we refer to go back to the instantaneous symmetrical component theory. And thereafter we can track, we can generate the reference by the neural network theory are the among others, and are some control approaches reported in the literatures. The 3-phase 4-wire system require a neutral current compensators along with the other UPQC to function. So, we may have a, we require extra switches more in case of the D-STATCOM, extra leg rather. So, classification of the UPQC, this is the classification of the UPQC. UPQC can be classified in many ways, such as we have followed that supply based, what kind of topology, what kind of supply it gets. So, for this reason it may have a single phase AC, that is 2-wire system, it may have a 3-phase 3-wire system, it may have a 3-phase 4-wire system, that is in a distribution level, and also the converter based, that is whether it is using the voltage source converter or it is using current source converter. So, for this example UPQC you can have a CSI, another is VSI. So, generally the cost of the inductor is quite high, and for this reason we generally do not go for the CSI for its commercial viability. So, we can go for the single phase 2-wire system. Here mostly power capability is limited, and generally we in India maximum possible load can be around 3 kilowatt, because 15 ampere you have a power for the single phase and 220 volt. So, it is around maximum load can be around 3 kilowatt. So, for this reason commercialization has a great challenge to use this UPQC for this level, and for this reason we generally prefer 3-phase 4-wire system with a neutral connected, and we mitigate a load for the 3-phase 4-wire system, and there we may have a different kind of voltage level. Generally 3-phase 4-wire system has a 440 volt line. So, there we can have a load up to around 10 kilowatt and or more than that, and 3-phase 3-wire system generally it is a distribution level, and it has a different variety of the voltages. It can be 11 kV, it can be 3.3 kV, it can be 6.6 kV, it can be 440 volt, and for this reason voltage rating required to be different, and to cater that voltage level we require a different kind of topology. For little lower voltage side we have a 2 level. Here this 2 level also it is used for single phase as well as mostly for the 3-phase 4-wire system. But in case of the 3-phase 4-wire system, since transmission voltage can be varied in a different voltage level, and for this reason we may require to use the multi-level inverter, because IGBTs, we know that cost of the IGBT goes high at the rate of the square of the voltage rating. So, 11 kV IGBTs, if it is available, nowadays it is available, and 100 and 1100 volt IGBT. So, you will find that the voltage rating has been maybe the voltage rating it is 10 times more, but you will find cost is 100 times more. So, this is the one of the challenge, and for this reason we try to have a multi-level inverter. So, we have a stress across the voltage level get reduced. Nowadays, with the penetration of the SiC based devices, we can expect that it can straight away throw away the power enhancement capability by 1000 times. Generally, IGBT can handle the power of in the rate of less than 100 kilowatt. If we use the SiC based device, it can go as high as around 1 meg level. So, anyway, so in a multi-level there is a many researchers are working to reduce the voltage stress and to reduce the component count and all those issues and optimizations, and for this reason we may have a conventional 12 switch UPQC that has been proposed. So, thereafter for the we may have a reduced DC link voltage based UPQC. There we try to reduce the DC link voltages by putting the capacitor in the shunt path, but real power handling capability generally it has been decreased. So, that is one of the problem, and we have a reduced switch, that is 9 switch UPQC instead of the 12 switch. Their number of switches has been reduced, but what happened, the conductions of the switches get increased. So, what happened, the switches are overloaded, and accordingly you have to take care of by the cooling. Commercialization and reliability and redundancy are the issues, and for this reason we have to see that the effectiveness of the 9 switch UPQC. That we can also have a 10 switch UPQC, that is compromise is that you get a 1 switch more, but what about the reliability and other issues. And same way we got a 8 switch UPQC. So, these are the few topologies can be used in case of the UPQC, and the many researchers are working for the optimizations of the UPQC switches. Now, we can have a classifications based on the topology. For example, if you refer back to the first circuit, so there is a shunt. Now, here shunt is at the right side, it can be also left side. Based on the right or left, we can have a classification of the shunt. So, example is the right shunt topology and the left shunt topology. So, classification based on these methods of control for this is and we can have a classification of the UPQC based on that of the control of this UPQC. That is, if it is just compensate the reactive power, that is it has to act as a over excited synchronous generator. So, then it is UPQC Q. So, it will inject the voltage 90 degree to the supply voltage and all those things, so that it does not take any real power. For this reason, real power handling capability of this device is least. Same way we can have a UPQC P that only compensate the real power, it injects the voltage and all those in phase. And then what happen, we can have a UPQC S, that is it try to optimize the KVA rating of this circuit, it can play either of the role. UPQC Q is a DVR used for the series voltage injection in quadrature with the supply current with almost 0 active power injection, and thus it required to just meet the losses of the switches and other non-linearity like inductor and capacitors all have a series resistances. So, those losses has to be accounted, thus it current power consumption is less, but it can only compensate the reactive power. Then second case is UPQC P, It uses the in phase series injections, that is all about, with the supply current with only active power injection. It cannot compensate the power factor. That is, we want that everything to be get a solution, and we can have a limited capability of enhancement of the power factor. Similarly, UPQC-S DVR based series injections, and it generally inject not only quadrature of phase, it inject in any angle, but its apparent power rating is constant. So, you can shift, you can, depending on the situation, you can take more P or more Q, and ultimately you can act totally as Q, and you can act totally as P, but and you can act in between also, but your apparent power rating will be constant. So, based on that, this is the overall pictures of this UPQC. These are physical structures. Based on the physical structures, we may have a VSI or CSI, that is current source inverter or the voltage source inverter, and based on the supply system, we may have a single phase. Generally, we require 2 H bridge of, since it is a low voltage. So, we require the 2 H bridges, the 8 switches. So, thereafter we may have a 3 legs. This is a little compensation, it's instead of the 8, we have a 6 switches and the 3 legs, and total is that half bridge or the 4 switches. 3 phase, we may have a 3 wire, and we may also have a 4 wire, 4 leg split capacitor and the 3 bridge. And the system configurations, we may have UPQC R, that is the right shunt, and that is preferred because voltage first generally compensate the voltage related problem, then current will take over, and ultimately it will compensate that current related problem. But same way we may have, but we can have a left shunt. Left shunt generally it is not been used because we want that voltage sag or swell has to be mitigated, so that there is no problem in the voltage side, and then current get rectified. But if we want to use current shunt, there is only single advantage, that sometime it will see the less rating in case of the soil and all those things. And you may have a interline UPQC that we will be discussing in detail in futures, and thereafter it is connected in between the 2 lines, and mostly it is connected in a transmission system more, that is intermittent. Thereafter we can have a multiple converter base, that is a modular structures, and you can go to the any level. Thereafter you got a multiple conversion, that you got distributed for conversion, you can have a distributed system, and mostly now due to the UPQC can be integrated with the solar or other energy sources or the battery, then we can say that UPQC DG. And based on the voltage sag compensations, they can be further classified on UPQC P, UPQC Q, that is for the reactive power compensations, real power compensation. This one is for the reactive power compensation. This is basically the kV optimizations. So, it will have a minimum VA, and this is QPS-S, that is a active reactive power, that amount is constant, you can choose the any compensation. Mostly this mode of operation is preferred. So, if I go back, what are the preferred mode of operation? Let us take a different color. So, preferred mode of operation is VSI. Generally we have 3 phase 4 wire system, and for the distribution level where it is used, and here it is right shunt is a preferred mode, and for this one. Otherwise, you may have a multi-level inverter, that is also a preferred mode, and maybe you may have nowadays a generating unit is incorporated with the power quality. So, that can be also with part of the system, and generally this is the preferred UPQC, that is the active reactive power compensation, both integrated into the single solution. Now, as I told you that two types of converters are used, that is VSI and the CSI. So, in the based on the mostly I have told you that this VSI are the used preferentially because it has many advantages. One definitely issue is that we require to put the DC link capacitor. DC link capacitor is generally less bulky than the iron and copper met inductor, as well as the cost of the capacitor is less than the cost of the inductor. And in case of the current source, our diode is used in series with the self commutating devices of IGBT, and we require a reverse blocking voltages. So, that is something it add up the costs. It is not there, and generally IGBT has anti-parallel diode. So, we require the bidirectional current operation in case of the in case of the VSC, voltage source converter, that is automatically provided. But the UPQC of current source converters are considered sufficiently reliable, but have higher losses and require higher values of inductive current storage in storage as the DC bus, which is bulky, noisy, costly, and as high as the level of the losses. Moreover, they can't be used in multi-level to improve performance of the higher rating. So, this is the one of the biggest drawback. CSI multi-level inverter, it is not possible, and output of the CSI is in pulsated format. So, that itself introduces little problem of the current compensation, and highly pulsed current, if you have a Fourier series analysis, you have seen that there is a huge amount of the harmonic content. And now, but if you have realized it with the current source inverter, this circuit would have been looking like this. So, because of this all reasons, the VSC based UPQC is been taken into the consideration and been used, but this is the way to implement with the CSI. So, you got a huge inductor, thereafter you got a huge transformer, and this is the path to be flow to the critical path, and it is not possible to have such a bulky inductor in a high power rating, and only only single phase 2 wire connections has been shown here. Now, UPQC can also be classified based on the topology, such as shunt UPQC and the right shunt and the left shunt. So, this is the right shunt UPQC. In the DVR, it is connected before the load in series with AC mains using a matching transformer to mitigate sags, swell, spikes, notches, unbalanced, and regulate the terminal voltage across the consumer loads, and to eliminate the voltage harmonics. It has been used to eliminate the negative sequence of the voltage to regulate the load voltage in 3-phase system. So, this is extensively used for this reason, and it can be installed by the electric utilities to compensate voltage harmonics and to damp out the harmonic propagation caused by resonance with the line impedance with the passive compensator. Generally what happen when you have adjustable speed diode, then 7 harmonics sometime become very prominent. And what happens generally, you got a leakage inductance of the peak transformer, that value is quite high, not negligible, and in assignment you are required to solve this kind of problems. And then what happened? All of a sudden, you know, you maybe switch on or switch off the capacitor banks that has been used for 100 years, and that leakage inductance and little change of the capacitor been introduced, and it may set to a system deviation of the perturbation, and thus it sets to a natural frequency of oscillations. And that natural frequency of oscillation may be if by chance become very close to the 7 harmonics or the 5th harmonics, then there will be a 5th harmonic resonance or the 7 harmonic resonance. It has the capability to mitigate or tamp out this resonance. Okay, this is the underlying statement of it. So, now let us have a discussion based on the classification of the UPQC based on topologies. So, this is the right shunt UPQC. It consists of the superior configuration as is reduce the rating of the both converter and requires the simple control, because already what happened, you have mitigated the problem of the voltages. So, control is simplified. So, you can get as quality voltage source and unity power, you can already available a quality voltage source. For this reason, unit template you can generate and do the compensations. And generally if it is a swell, this swell has been mitigated, so rating of these devices are less, and it is the healthy notch free, no disturbance from the voltage sides. But ultimately this DBR takes the bucks. So, another is the left shunt. It has drawbacks of the high cost definitely because of the complexity required to be more, and the generally voltage will be uncompensated. So, here you inject the voltage, here you inject the current, and here you inject the voltage, and for this reason right shunt is considered as a better option to deal with. But sometime it is been preferred, while we will see that the rating of the DVR is required to be reduced, or this kind of cases that we prefer this kind of situation. Thank you for your attention. We shall continue to our discussion in our next class. Thank you for your attention. We shall continue our discussion with the UPQC in our next class.